the operator that's actually doing the work on the plant folio level. That, in this case, where, for example, he's trying to resolve a deviation for a batch. Somewhere, maybe on the other side of the world, they've had a similar deviation. They've successfully resolved it. That's all been documented. Here, the agents can work together between the Tulip agent, the Cognite agent, can go out, it can query the knowledge graph, find that relevant reference, and then provide that to the user so they can quickly resolve that and they don't have to spend hours trying to figure out, how do I resolve this batch?
But the data, the historical data from the batch records, who owns that? Is the idea that the customer where this solution is going to get installed, they already have that history, or is this something they're getting?
No, we don't bring in new data. And actually, with all of our AI and agents, they're all structured to leverage the customer's data.
Okay.
And only in a transactional manner with the customer's credentials. So, for example, if there's a operator, again, in a healthcare, in life sciences setting, that has access to only certain data, the agent they use is only going to have access to that same data. So you can deal with all the...
Are you coming to prove it? Are you guys one of the sponsors to prove it? Is Cognite one of the sponsors?
No, I don't know.
I don't believe so.
Okay.
But
well, we should talk to you guys about it once you do.
yeah, okay.
So, because we're doing a life sciences virtual factory this year, so we're doing 3 virtual factories. Yeah, Skellig is building the life sciences virtual factory. So, and it is bioreactor centric. So,
Okay.
so it might be a perfect scenario for you guys to show off. Well, we can talk about Prove it a little bit, but all right. So, but here's the reality in the market right now. The potential for the technology is way out here, right? If we talk agentic AI, so not autonomous AI, I hate that term. Like it's more synergistic artificial intelligence, human and AI working together, augmenting one another. AI makes human faster, force multiplier. Human being makes AI accurate, right?
Yeah.
That's the relationship. So the potential of that technology, right, with model context protocol and large language models, large reasoning models, is way out here. And where what the market is doing with it is like here, right?
Step 0, maybe.
Right. And what I'm going to speak about today is kind of what people are doing today. So you've had a chance to see like the art of the possible way out here, but what are people actually using, model context protocol and agentic AI for today? Right. So with this though, this example here is possible today, but it's out here at the outer limits of the capabilities of the technology, right? So some of the obvious, as you go through this demo, some of the obvious questions are going to be, how are we confirming that what the agents are recommending can be trusted, right? How are we, where does the human being's role come in? Like we want to make sure we touch on that piece. But then more importantly, where is this 1 year from now? Like, in terms of what we have here. So if you want to go through, are you going to run this demo from scratch or?
I'm happy to, or we can just talk to it at a lab.
Okay. All right, let's do that. Yeah.
Okay. And to say, these are demos with human in the loop, right? We're not making decisions yet. We're trying to, as I said, help the operator or faster as a force multiplier, or get them to resolution faster, or even as a source of context to these data models that can make it.
So what we're looking at here is we're looking at Tulip.
Yes.
And we're looking at Cognite.
Well, this is also Tulip, but this is our agent history from Tulip talking to a Cognite.
Okay, got it. And Cognite's running over here. And Cognite and Tulip are connected together how?
So we are sending data from the operator context, the app running, up to Cognite, right? Yep. Storing that as additional operator.
Over what? Over REST? Over how?
We're publishing MQTT.
Okay, so through an MQTT.
It can be REST. We've got over 100 connectors to various protocols, everything from ECUA through APIs.
So we've got a Cognite tenant running where we've got a key that's allowing us to connect to our tenant, and we're basically publishing data from operator context in a Tulip application up into Cognite.
And from Tulip, we're pulling down the enterprise context as relevant to inform that outlook.
Okay, perfect.
And then on top of that, we have agent-to-agent conversation to do this kind of deeper knowledge graph, descending and pulling together information across all of their data.
And so you have an automation set up in Tulip right now. So if deviation, then
Exactly.
Okay.
So here we're seeing live data streaming from a bioreactor from a process. Once we get outside of deviation parameters, we're going to create a deviation, and then we're automatically going to, with an automation, call uh, Cognite and say what other processes like this deviations have happened and what were the resolutions. So we can now give the operator guidance towards what the best step they can take to resolve that deviation is. So this is now, right? We can build this now. This is acceptable to pharma standards, right? They're comfortable using this kind of stuff. Now we move into something that's a little bit more cutting edge, which is really investigating why this batch has gone bad and what we can do and how that affects production. And in this example, we have a tool.
So in a normal case, this deviation means we got to scrap the batch. Or can we mitigate? Can we intervene?
So if you look at all the historical data, which a process engineer would do in Canvas later, this batch is likely to complete, but at a significantly delayed end state.
Got it. Okay.
So cell growth is going to plateau and then go very slowly, and then harvest is going to be 10 days out.
Got it.
At this point in the batch, an operator doesn't know, so they're still working on their expected harvest timeline.
Okay.
And what this agent is doing is, or the two agents are talking, they're comparing all previous batches, like deviations, current state now, previous state, and saying, based on this, I estimate this batch is going to end 8 days later. Example.
Good.
Now we can take that context back and we can go to a scheduling and
Which is
push this forward.
which is a perfect use case for deep reasoning, right? I mean, it's a perfect use case. Yes, sir.
Right. And we're tweaking these, we're using GPT-5 mini here and something else here and adjusting these two agents because they're both very customizable. It took us about a week, if unpacking, to tune both of these agents to work well together.
Got it.
Now we can build on top of that for other.
Because one of the things I keep talking about is when we look at like the real power of agentic AI, especially with model context protocol, basically, again, for those I'll talk more about MCP later, but at the end of the day, model context protocol connects agents to applications. It's a software, okay, whereas REST connects human beings to software in general. The real potential is when we look at, as the large language models, as the models improve, are the performance of our agents improve. In theory, right? We hope that they improve. The fundamental difference between the way that we integrate, if we were going to integrate this solution pre-agentic AI, we have to come up, a developer has got to create a knowledge graph of all the possible permutations through this reasoning. And if we wanted to write logic that was going to automate this, we'd have end to the eighth, possible permutation, where you wouldn't build it because that's the reason you don't have it, because it was cost too much money to build it. All right. Agents now are able to just create the work through the logic of the next permutation as it's reasoning on the fly. So now that doesn't cost dollars. It costs compute, and that's it. It doesn't cost anything else, just compute. It doesn't cost engineering dollars. So now the beauty of this is what I keep saying, the real power in agentic AI is that as the models improve, the integration that we created in theory is going to get better as the models get better. But if I build that same integration, that same logic into a REST API, the outcome will always be the same, assuming the underlying data it's working with doesn't change. The structure doesn't
get more and more outdated over time.
Correct.
Whereas this will continue to evolve as you feed it more context.
Correct. So that's if everybody wants to know why it is they should be using agents, it's because it's not so much that the agent is a silver bullet, right? It really is a lever. It's the nail gun to the hammer, right? It doesn't build the house. It just gives the carpenter the ability to build the house faster, a nail gun does, right? So, but the real power in agents is that a single integration will continue to improve as the models improve, right? We'll get better and better and better outcomes.
And we've seen this, just tweaking this over the past week or so. As we went kind of up the levels, right? We're using 5 and it's a bit slow, but the answer is incredible, right? And sort of, let's trade off. Let's go to mini and we'll see this answer is good enough. Let's tweak it a little bit. And we can see as we kind of step up the levels of, insights.
So where do you find, so what you have are two agents that are working. So what is the objective of agent A and what's the objective of agent B?
Yeah, good question. Actually, where's Thomas? He could talk to this, but I can attempt to. Yeah. The Tulip agent is a batch investigator agent. So Cat's job is to resolve this batch and understand what's wrong with it and give context on how it could be brought back to a normal computer. The Cognite one, not so sure. I think it's set up. Yeah. Do you want to?
So the Cognite agent is designed to answer questions about batches. So everything from the history of the batch to also just provide information around what's gone into the batch and deviations related to the batch. In a knowledge graph, you can explore from multiple different directions. You can say, and the agents are set up to want to explore it in a specific direction. So you could have an asset investigation agent that's been prompted to investigate towards assets and work orders. This agent is prompted to look at the batches and traverse the knowledge graph that way.
Got it.
So this agent is not specialized on deviation resolution. This agent, for example, could also answer questions on, what batches fed into this batch, what are the child batches of this batch.
So this agent has been trained to, or it's been instructed,
Yes.
to answer questions about batches, and you have fed it a knowledge graph that scaffolds the way it reasons.
Yes, and it's allowed to traverse the knowledge graph, and then also this agent has other agents or tools that it can call to solve specific problems.
And how many tools does it have access to? Is it a single MCP server? Is it many MCP servers? And what is the total number of tools it has at its disposal?
So
Ballpark.
in this, it's typically on the order of a couple tens of tools
Okay.
that we use. To be technically correct, for some security reasons, we are not implementing MCP here yet because there's security on MCP is still evolving. So in a couple of years,
Basically non-existent.
Yeah. But it's the same philosophy,
Right. Yeah.
Which
Which is the reason that they have you spin the MCP server up when you want to use it and then take it down when you don't want to use it.
Yeah. But it has these tools, and with the tools though as well. With our agent, it's not just other MCP servers or querying specific data. You can have tools that do things like run an explicit workflow that is programmatically defined, or, for example, construct code to do specific statistical analysis, which in some of these use cases where you might be in a validated environment, and, for example, around a deviation, your SOP says you must do these 7 steps, then you can have an agent that is actually calling a repeatable workflow. So then the human can say, yes, this matches my SOP, and it gives you the exact right output every single time with that referenceability. So there is flexibility in what the agent can call.
When did you guys develop this? Did you develop it specifically for ops calling?
Yeah, we built it last week.
Okay, so has an operator in life sciences come by and seen what you're doing here?
We've had quite a few companies come by, very excited.
What about did Amy Williams from Skelly come by and see it yet?
I don't know, but
Okay.
I would love for her to see it. And
Yeah, Amy would be. I would love to hear Amy's.
take for this.
Yeah, she would be a perfect. She would give really, really good feedback on it. I mean, that's what she specializes in. So, where do you see the limitations? So when the agents are working back and forth, if they're having a conversation, basically there's a deviation that their automation, sends data to Cognite, and now you have 2 agents that are working together. They're having a conversation, trying to ultimately diagnose what the issue is, and then make a recommendation on how to intervene. Right?
Yeah.
Where do you see the limitations in it when you're working through this?
Yeah.
Kind of where are the guardrails?
So we just felt the pain of doing this last week. So it's fresh and we're still building on top of it. It's very exciting. But I think one of the things that's been the most challenging and interesting is getting both agents to be aligned on the same goal.
Okay.
Even if you give them like literally the same goal, sometimes they don't understand this. They're not aligned. So they're feeding themselves slightly different data. So you have to build your agents to be resilient and to continue to ask questions and refine with each other. So
are you using agent to agent protocol?
Yeah.
Okay. So you're using agent to agent for the agents to talk to one another. Okay, good. Perfectly. All right. So that's the ideal standard. Google did a pretty good job with it.
storing this memory, they're taking that,
Right.
they're responding to it. Yeah.
But the big issue you're having is syncing them on the same objective.
Yeah. And just that you may talk about a specific batch and it will go pull Kappa reports that have a reference to that, but really we want the batch data. So to understand what each agent's goal are, and then to be willing to, or give the agents enough leeway to retry, ask themselves, so to clarify. And so if you look at the example conversations, often the first 2 results that we get back are not quite right, and the agents are refining. Got it. Been instructed this way to kind of continue to drill down, as opposed to just give a high-level general answer, which sometimes they're inclined to do.
And how are you currently handling hallucination? Is it if there is a hallucination, we're screwed, or are you backing out of do you have it set up so that the agents are backing out, recognizing a hallucination and then backing out of it? Or is it, hey, let's avoid hallucination at all costs?
We're trying to avoid them at all costs, but we have in these examples are backing out. So we have an idea of what our resultant data structure should look like.
Okay.
Should things
So you are doing your
not
checks.
like this, we're saying, hey, this doesn't look right. Let's go back and look for some this. And so that's what you can see.
And so for those of you who are like, everybody is familiar with what a hallucination is, but it's basically when an agent essentially starts making things up. But I don't think most people understand where they actually come from. So they really come from one of two places. Either the context window fills up and information that they had, data information they had in the context is no longer there. And so obviously it's like having amnesia. The agent basically has amnesia, it hits the context limit. But the bigger issue and the most common use case, the most common cause of a hallucination is conflicting data. If I'm retrieving data and I get two results that are in conflict with one another, the agent will make up a third one that is totally made up. It won't choose between, unless you instruct it to choose between the two or reason through it, it will just make up a third option. And that's where the hallucination comes from. So data integrity, managing context is so important. The interesting thing here is the agents are managing each other's context. The human being is not doing that during this process, but really at the end, right?
Yeah, and then they're reviewing this and also
Right.
having a basic logical check. But yeah.
Okay.
And one important piece around avoiding hallucinations too is having the agents be instructed to be able to provide references for what they're providing. So at the end, the human can say, all right, you told me this is the relevant deviation. I want to see that investigation report from that deviation and show me which page of that investigation report you generate this recommendation from so I can go and check.
Okay.
So when you construct agents, it's incredibly important in an industrial setting to have that referenceability back to source material so a human operator can quickly say, yes, this is not a hallucination. I have complete confidence in what the agent has recommended.
What about, are you guys doing anything elegant with artifacts? It's like, so using artifacts in a very long form, deep reasoning, objective with an agent is a really sophisticated way of avoiding hallucination. Like when Anthropic came out with Sonnet 4.5, you saw the prompt where they basically rebuilt Slack in 30 hours. They had one agent run for 30 straight hours and it didn't crash, and it managed hallucination and the whole deal. And it was able to manage its own context window by basically creating artifacts, and the artifacts would just sit in memory and that will reference the artifacts as needed. Are you doing anything like that here? Or do you really just go agent to agent? Let's have a conversation.
This is agent to agent. This stuff is really exciting. The artifact.
Yeah.
Haven't explored it yet.
So
Really see it being.
and you were able to get this,
content.
you were able to get this outcome without using artifacts. Okay. That's even more impressive, actually.
Yeah.
There are
Yeah.
Tweaking.
there are some customers that we work with where they want to store that for long-term retrieval. And that's where also the knowledge graph,
Because now for quality control reasons, right? And for further training, if I store the artifacts that the agent is generating, then I can go and as a human, I can supervise the process.
Send the logic
Right.
logs.
I can, right. Exactly.
because you typically will have the instances in a knowledge graph that were used to generate that artifact, they get contextualized back to the knowledge graph. I mean, classic case, if you have a agent that's monitoring equipment for abnormal performance, when it sees an output, it can take that artifact, contextualize that against that specific asset. So then when maybe later and someone else is coming back and with another review of that, they can actually retrieve those artifacts and then be able to summarize those into a more concrete overall answer. So our approach is actually to contextualize those back into the knowledge graph so they persist. And it's not a question of, oh, is this available for 7 days or 30 days? No, it's there, it's forever.
When you did this last week, I mean, this is what you guys are famous for at Ops Calling, is basically building everything last night. And it's like, it's some of the most impressive stuff. I'm like, well, you guys really, yeah, we actually did this whole, the t-shirt.
Great.
Yeah, we did it last night at 1:00 in the morning. It's like, it's one of the most amazing short time to value with Tulip is like sort of the brand. It's the brand name, right? Yeah. But where did the use case come from? So what made you say, hey, Cognite's going to be here, let's do this use case? Where did that come from?
Yeah. So life sciences has been a really, I'd say, growth area for both of our companies, and the pursuit of a golden batch or trying to, is the ultimate.
It's the ultimate. Oh yeah, it's the holy grail.
Hey, why don't we take the hardest problem, see if we can solve
Right,
that?
right.
One agent.
Why not?
Shot.
Yeah, and And it paid off. It paid off.
I mean,
yeah,
it's a demo certainly, but it works quite well.
yeah, that's awesome. All right, where's it going? You think?
Well, it's going to your conference next week. We're gonna display it there.
We're demoing this at our Impact conference in Houston next week.
Okay.
We have another number of customers that are working with Cognite in healthcare life sciences. We were kind of 4 of the top 10, and they're very interested in deploying some of these use cases, especially around batch agents and also resolving deviations around batch agents. Because as Dylan mentioned, things like batch hold really impact your ability to deliver product on time. They force you to reschedule, and as pharmaceutical manufacturers are going to more individualized therapies, smaller batch sizes,
That approach.
they don't have that flexibility in their schedules, and they can't take 30 days to resolve a deviation. You know, they got to resolve it in 4 hours, or they miss their ship date. So, there's a lot of interest in these sorts of use cases with life sciences customers to get this out there, and then using products like Tulip to get the action from the corporate knowledge into the hands of the operator that's going to.
Honestly, this is what you guys should do at Prove It.
Yeah,
You should bring Cognite. You guys should do it together,
would be very.
and you should do this, because no one else is going to do it.
Yeah,
There's not going to be a comparable Prove It session. And I mean, the number of you're going to have you have Siemens Life Sciences coming. You have like all these companies are coming to see integrations on a life sciences virtual factory. And by February,
we should have this.
you'd have it. I mean, because we're giving you guys the documents. You guys can start building your sessions 3 weeks from now. You'll have access to the virtual factory 3 weeks from now. So, but honestly, I'd highly recommend, inviting Cognite and doing this. So
That's a great,
awesome.
great place to prove.
Dylan, appreciate it, brother. Thank you.
Nice to meet you.
Thanks, John. Thank you. All right, that's it.